Hello, my name is Ethan Moriarty, and I am the founder of June 1st Severe Weather Research, and today I'm going to be talking a little bit about the project that we are undertaking as kind of an introductory video to this video series that I plan detailing the design process of our latest project. So a little bit of background. I'm a senior mechanical engineering major at Quinnipiac University, and I am partaking in my capstone senior design project that culminates all my skills as an engineer and puts it into designing something that solves a particular problem. Now, I'm not alone in this endeavor. I have 3 other engineers that are working together to create this project. And how this came about was after I did an independent research project over the summer of 2019 that was inspired by my love of severe weather and wanting to understand how supercell thunderstorms can produce tornadoes. So I generated a proof of concept tornado probe that would gather locational and atmospheric data from within supercell thunderstorms to prove that it could be done. The senior design aspect of it now is to improve upon said design and rework the problem a little bit and create a much more full solution that could actually be implemented in the field. These initial stages of the project are very broad as we kind of define the problem at hand and kind of narrow down parameters and do a lot of background research to fully immerse ourselves into the problem before we can start implementing solutions to the problem. You have to understand said problem to propose the best solution possible. To start, myself and my team had to do a lot of research to fully immerse ourselves into understanding the meteorological aspect of things as well as what previous research has been done in order to understand tornadoes and supercell thunderstorms. We also decided to do a lot of pooling, of talking to storm chasers and field researchers to better understand what they would be looking for in something in a tool that would be used to study supercells. After that, we decided to formulate a problem statement that kind of encompasses the entire design in a very kind of broad sense, but kind of covers what we are looking to do in a few sentences. So our problem statement for this project is that we need to design a system of devices used to gather atmospheric and locational parameters within supercell thunderstorms. The system must be safe, durable, reusable, user-friendly, and take reliable measurements. The design must be transportable, deployable, and ready for use by May of 2021. Some of the key things that we gathered out of our research aspect of this design project thus far is that there are a number of things that need to be prioritized in order to deliver the best tool possible. And number one that paramounts every other aspect of this design is safety, in terms of those using it in the field and those that would be possibly affected by it. So once again, safety is paramount. We want to ensure that chasers or field researchers are not in the path of dangerous supercells or putting themselves in line of a potential tornado, large hail, or anything of that matter. Granted, there's inherent risks with storm chasing, and we don't want the tool to make them move any closer than they have to in terms of where they are relative to the storm. The other thing we need to ensure is that if we're putting a measurement device into a supercell, eventually it's going to have to come back down to Earth, and we have to ensure that it's not going to be harming bystanders that it could be potentially above as it comes back down to Earth. So we have to ensure safety from both the chaser perspective as well as a bystander perspective. In terms of parameters, there are a number of them that we want to take care of in this design. So from the measurement device aspect, as right now in this initial design phase, we are kind of chunking up things in a very broad sense, so that, we have a device that takes care of the measurement aspect of things, a device that takes care of the deployment aspect of things, as well as a monitoring system that can monitor both the deployment system as well as the measurement system. So right now, we haven't gotten into real specifics on how we want to accomplish this yet because we want to fully understand the problem first and what we need to do before we start proposing solutions, like I mentioned earlier. But the parameters that we want to measure in supercell thunderstorms break down into 3 main categories: locational, atmospheric, and movement. So in terms of locational, we want a 3-axis system that can define it in a 3D space. So that being altitude, longitude, and latitude, to get a full picture of where this device is. Compared alongside radar data, you can get a 3D picture of where this thing is in the storm. In terms of atmospheric, we want to make sure we can measure temperature, relative humidity, and barometric pressure, and those would give us a good idea of what organelles, you might say, the device is in at a given point in a supercell. The third is movement. So we want to be able to keep track of the velocity, the acceleration, and the orientation of the probe. And then all of this at the same time is also going to be monitored by a real-time clock so that we can have accurate time of where this thing is compared to accurate time of, say, radar data, for example, so we know where it is exactly at each given moment relative to the storm, which is important for accurate data purposes. The inspiration behind this project is that we don't necessarily understand what separates tornado-producing supercells from non-tornado-producing supercells. And in order to do that, we need to start engineering the tools in order to better understand trends between producing versus non-producing supercells. Granted, I'm an engineer and not an atmospheric scientist, but as an engineer, I need to be able to implement the tools that could be used by atmospheric scientists to better understand how these supercells can either produce a tornado or not produce a tornado in order to increase warning time and warning accuracy, as tornadoes are the most unpredictable atmospheric natural disaster that can occur. I hope this gives you a good idea of what we expect to do with this project. This is kind of an introductory video as we haven't gotten too far into the design aspect of things. Like I mentioned before, we're really covering our bases in terms of the research aspect of things to ensure that we fully understand the problem at hand. There will be future videos, as this will be a video series documenting the design process of this system. And I hope you are going to tag along, subscribe, and watch as we develop this system. We have a deadline of May of 2021, as we hope that this upcoming storm season will be the perfect chance to maybe start collecting data on supercell thunderstorms and maybe start pushing the boundaries of science to better understand these supercells. I'm Moriarty. On behalf of June 1st, thank you for watching.